Now that we have learnt about the three states of matter, today we'll talk about interconversion of states of matter. How one state of matter can be transformed into or converted into another state and therein also get back. Okay, so the phenomena of change of state of matter from one to another and back to its original without changing its chemical composition. It is only the physical state that changes, chemically, they remain the same. So, this process, this phenomena is called interconversion of states of matter. So, we take the three states of matter, that is solid, liquid, and gas. Okay, so what we want to do is from solid the matter is being changed to liquid, from liquid it changes to gases. How does it happen? Okay, so if we talk about the molecular arrangement, then we will discuss this with one example also. So the molecular arrangement of solid, they are closely packed, and when it is heated, so what happened? The force of attraction between the molecules reduces. Okay, so the movement of the molecules increases, the space increases. Okay, as you have argument with your friend, and then what happens? You sit in one corner, and your friend sits in another corner. Similarly, so the kinetic energy, here it is, there we are angry, here it is kinetic energy. So because of rise in temperature, heat, the kinetic energy of the particles increases, the force of attraction between the molecules are broken, it becomes more than that, and therefore the molecules move apart. So as they move apart, what will they form? They form another state of matter, that is liquid. So on heating, the kinetic energy increases and therefore solid changes to liquid. Now again, if we further keep heating this, then what happened? More anger, isn't it? Someone comes and tells you something, oh, you fought with that friend and so said this. So now anger will increase. So previously you were sitting in one row maybe, but now you will go in two corners of the class, isn't it? The anger is increased. Similarly, if more heat is given to this, then what happens? More energy is gained by the particles. So the movement is more. Therefore, the force of attraction totally is overcome and liquid is converted to gaseous state. Okay? Just the vice versa happens when they are cooled. So when gases are cooled, when it is cooled, then what will happen? The molecules will come closer, force of attraction will increase, and gas will change into liquid. Kinetic energy will reduce. From liquids, again when it is further cooled, what will happen? The molecules will further come closer, the force of attraction will increase, and they will be converted into, and kinetic energy will be reduced, and it will be converted into solid. Okay, so this is how the solid can be converted into liquid, the liquid can be converted into gas, but chemically the substance remains same. Let us talk about explain this with an example of water. So if I take some water in a bowl and heat it, right? So what is happening? We had taken liquid water, it changed to gas, but it remained water. Chemically, it remained water, that is H2O. Similarly, if I take a bowl of water and keep it in the refrigerator, it will cool, okay, and the liquid will become solid, that is ice. So, therefore, it turned into ice, that is only the state changed. The chemically, water did not change. So, this was ice, this was water, and here it produced steam. So let's draw it here. So this is water, this is ice, This is water and this is water vapor, or it is also called steam. Fine. Now, this change of state of matter, what did we see? What was the factor? What helped it to change? That is change in temperature. So, we saw this, that by changing the temperature, the state of the matter changed. It can also be done similarly with pressure. So even when pressure is changed, the state of matter changes. Okay, a gas can change into its liquid state and then into solid by cooling it. Okay, and by increasing its pressure. And also by increasing its pressure. So therefore, by increasing pressure of certain substances, we gain liquid hydrogen, we gain liquid oxygen, which are also very useful for different purposes. So two factors because of which interconversion may occur. Two factors because of which interconversion may occur is temperature and pressure. So here we will see the terms which are related to the interconversion of states of matter. That is, when solid is changing to liquid, liquid is changing to gas, gas comes back to liquid, or there is some direct change of state of matter without entering the phase of liquid state. So what are the terms involved in it? First we go. Now, all the processes that we will be studying here can be defined by using certain set of words, and that helps us to remember those definitions which I have written on both the sides of the board, whichever I require, which and when I'll be guiding you. So here we're talking about melting and fusion. So what is happening? The process by which a substance changes from which state? From solid state. So here we just write from solid to liquid. Solid is becoming liquid. So how can a solid become liquid? By heating, isn't it? By heating or gaining energy. Or by gaining energy. So this is the process of melting or fusion. So here you can take the example of ice. You can see I've taken some ice, and when it is kept outside, it is absorbing the heat of the atmosphere, and therefore it is changing into water. Okay, the solid ice is changing into liquid water. Fine. Now the next process, evaporation. So here what we'll write, what will be the changes that we need to make? That is the process by which a substance changes from, now we'll write liquid to gas. How does the liquid to gas occur? Again, by heating or by gaining energy. So gas. So here I have taken some water and I am heating it, and you can see the water vapor coming out. So therefore the liquid water is changing into its gaseous state, that is water vapor or steam. Okay, so what we will observe, that the processes which are written above, that is melting, fusion, evaporation, all occurs because of gaining of energy or heating. Now the processes that we are going to discuss here, that is condensation and solidification or freezing, you will see that it occurs by cooling. It occurs only on cooling or losing energy. Here, these processes occurs because of heating. So, but the sentence will remain the same. Now, if we talk about condensation now, the process by which a substance changes from gas or gaseous state to liquid by cooling or losing energy. Cooling is losing energy. It's called condensation. So the best example of condensation is the clouds. Isn't it? The water droplets in the clouds, when it reaches a cold area, it changes into the water vapor in the cloud changes into water and it falls on the earth. Here I am showing you with the experiment where in the bowl in which I heated water, we saw the water vapors coming out. Now I am going to place a plate which is cold on it. Okay. Now after I place it the lid, what happens, the water vapors comes and strikes on the colder, comes in contact with the cold parts of the steel plate. And now when you pick up the plate and see, what will you observe? You'll see the water vapors have already changed into water and you can see it dropping from it. So this is also condensation. Okay, talk about is solidification or freezing. This again can be explained by this sentence. The process by which a substance changes from, which state are we now talking about? From liquid to solid by, it will remain same, the lower part, cooling or losing energy. Okay, so you take some water, and you are taking some water and keeping it in the refrigerator for some time. So when I take it out, what do I see? On cooling, it has turned into ice. So this is solidification or freezing. Okay. Now talking about melting point. The melting point is the fixed temperature at which a substance changing from solid to liquid. It starts changing. Okay. A substance starts changing from solid to liquid. If you take the example of ice, if you keep ice outside, it starts melting. So that temperature from at which it starts melting is the melting point. Okay. Now as because we are varying the temperature, so the pressure is kept constant. That is at atmospheric pressure. Atmospheric pressure is measured in terms of millimeter of Hg, mercury. Okay, in the atmospheric thermometer in which it is measured, it is taken to be 760. That you might not be knowing, just for your further knowledge, what how much atmospheric pressure? 760 millimeter of Hg. That is how it is calculated, measured. Okay, so now talking about boiling point. So here boiling point. So in boiling point, what is seen? It is also fixed temperature at which a substance starts changing from liquid to gas. The water boils, you saw it, isn't it? From liquid to gas at atmospheric pressure, that is 760 millimeter of Hg. Okay, so what happens? The water that is taken, it starts boiling at 100 degrees centigrade. That is the boiling point of water, but it will remain the same. The temperature will not change till the full water has changed its state into vapor. Okay, so now coming to condensation point. So here it is also a fixed temperature at which what happens? Condensation starts occurring. That is, the gas starts changing into liquid. So the fixed temperature at which a substance starts changing from gas to liquid is called the condensation point. So this is also 100 degree for steam when it starts changing into water. As you saw, I kept the lid on the container, and then only at that temperature itself it started changing into water. Okay, freezing point. This is also fixed temperature at which a substance starts freezing. That is, from liquid it changes to solid. Changes from liquid to solid at atmospheric pressure, that is 760 millimeter of Hg. Okay, so the freezing point of water is 0 degree. So you see water also melts at 0 degree. Okay, so water, the 0 degree temperature is said to be a triple point for water, where it freezes, it melts. Okay. Now, talking about sublimation. The sublimation is the process in which the substance changes from solid to gas on heating directly. So it doesn't become liquid, it becomes gas straight away from solid to gas. There are few substances which has the capability of being sublime. They are like camphor or ammonium chloride or iodine, naphthalene. You must have seen the naphthalene balls kept in among your clothes, woolen clothes, or in the almirah, and they become smaller on its own. How is it happening? Because from solid it is directly changing into gas and mixing with the atmosphere. So here I've taken camphor and I'm going to light it. Just check out what happens. So you see, when I light the camphor, it burns. It is getting heated and gradually it disappears. Why is it so? Because it directly changes from camphor to its gaseous, solid camphor to gaseous state, because it is a sublime substance. A famous scientist, Lavoisier, gave us the theory that the law of conservation of mass, that is, matter can neither be created nor destroyed during a chemical reaction. That is, whatever substances are taken as reactants, their weight, when taken, will always be equal to the weight of the products. Okay, so whatever reactant has been taken, we measure it, and then after the products are formed, whether gaseous or liquid, and then if the weight can be measured, both will be found to be same, to support the statement that matter can neither be created nor destroyed during a chemical reaction. So we'll see one reaction to prove it, like if we take barium chloride, BaCl2, plus sodium sulfate, Na2SO4. So they will react, and what is formed? BaSO4 and NaCl. Okay, this remains as a solution, and this is produced as a solid precipitate which remains suspended. If the weight is measured, before experiment we measure the amount of barium chloride and sodium sulfate taken, and after the reaction is completed, if we measure the weight of these two, then what is found? That the total weight remains the same. It will not change. Okay, this is law of conservation of mass. Same thing we can do with the magnesium ribbon. We burn it, magnesium oxide is produced. Magnesium produces magnesium oxide. So if when weight is taken and compared, it's seen that no weight change has occurred. So proving that nothing has been created, there is no loss of weight, therefore nothing has been lost too. Okay,